Hey, Algebra 2 and Honors Algebra 2 kids, let's go ahead and start with Unit 3. I'm on page 47 of your student journals. And the first thing we're going to talk about is just a couple different vocab terms. So quadratic equation in one variable. Really what they're asking about here is they're talking about like kind of standard form of your equation. So ax squared plus bx plus c. Remember, a, b, and c are the coefficients of your x squared term, your x term, and your constant term. A root of an equation. So the root of an equation, there's a couple words that we use to represent. So there's three words that would kind of come off the top of my head that we use to represent almost the same thing. So we use root, solution, and x-intercepts. And basically what this means is that we are, like, it's the answer when you're solving a quadratic. So a root is another name for a solution. And an x-intercept can be a solution to a quadratic. It's just more specifically those solutions that cross the x-axis. So for example, if we have, which we're going to get into, imaginary solutions, those are going to be ones where the graph does not touch the x-axis, and therefore they would not be considered x-intercepts. They'd be considered solutions, but not x-intercepts. Another word that we use is zero. So a zero, a lot of times we use is like, it's talking about like basically when you zero the function. So you're solving for x. And so what you're getting at here is generally real solutions when x equals 0. You can get imaginary ones as well, but that's kind of what we refer to. So there's kind of like four words to kind of represent solving in this. All right, so we're going to be talking about how to solve by graphing, by using square roots, and by factoring. So I'm going to kind of go through a couple examples, just so you guys can see kind of a process for each one. So if you were going to solve by graphing, so let's do, I'll call this example 1, and I ask you to solve x squared plus 3x minus 10 equals 0. So notice that I already set it equal to 0, and that should be your first step when solving an equation, is set it equal to 0. The next thing is you're going to want to graph it. And so if you use your graphing calculator, you would find that your parabola would, 1, 2, 3, 4, 5, it would look like this. All right, so there's my parabola. And so if I'm literally solving this by graphing, all I would do is say x equals 2 and x equals negative 5. And so that would be my solutions. Now, if I was going to solve this same equation, but I wanted to solve it by factoring, let's say. So let's say I had x squared plus 3x minus 10 equals 0, but this time I'm going to solve by factoring. So when you solve a trinomial, this is a trinomial, it means three terms. This is the factoring technique. Remember, what two values multiply together to give you x squared, and then think of two numbers multiply together to give you negative 10, but add to positive 3. So that would be positive 5 and negative 2. So again, those two numbers multiply to negative 10, add to positive 3. And then at this stage, you would set it equal to 0, and then you would get ultimately the same solutions. So you would get x equals 2, x equals negative 5. So again, this is kind of how you solve it by factoring, solve it by graphing. You can ultimately solve it kind of the same way. The square root method. So we use this a couple different ways. I just kind of want to write a little note here. So for the square root method, I use this predominantly when I have like an ax squared plus c. So I use this when I have no like x term in the middle. So what I'm getting at here is if you think back to your standard equation, there's no middle term. There's an x squared term, but there's no like x term. And so generally in this case, you would set it equal to 0 and you would square root both sides to end up solving. And I'll show you an example of that. Another example of when we use the square root method, which we'll get to in a minute, is if you had vertex form of an equation. So if you have no middle term and if you have vertex form, we generally use the square root method. Factoring we use with trinomials, but we also use with binomials as well. So factoring we use, we can use with any kind of trinomial that is factorable, obviously. And we can also use it if we have a binomial, which just means two terms, but this is different than the one I put up here. This one has a B term, but not a C term. So this one, normally for factoring, if you have an x squared and an x, you can solve it by factoring. But if you have an x squared and a constant, you solve it by using the square roots. So always our first rule of thumb when we're factoring or anything else, to be honest with you, with any kind of thing, you always want to factor out a GCF first. And do you guys know what GCF is? It's greatest common factor. All right, let's go for a couple more examples. So I'm on page 48. Zero product property, just as we've already kind of used that. It's what you do when after you solve or after you factor and you set those equal to 0. So let me show you another example. So this one says solve 2x squared plus 14 equals 70. So notice there's no b term, right? So there's an x squared and a constant term, and then there's a number on this side. There's no x's. So this is where we're going to use the square root method. And so I'll show you what that looks like. So ultimately what you're going to do is you're going to get x squared by itself. So I'm going to subtract 14 from both sides. I'm going to divide both sides by 2. The biggest mistake I find when solving the square root method is forgetting the plus and minus. Anytime you square root both sides of an equal sign, you have to put the plus and minus because there are two possible solutions that would satisfy this equation. So like in this case, square root of 28, if I reduced the radical, would be what? 2 root 7, right? So positive 2 root 7 squared would give me 28, and so would negative 2 root 7 squared give me 28. So anytime you square both sides of an equal sign, you are going to use a plus or minus. And that's going to be important when we get into like the quadratic formula and so forth, but it comes up in the square root method as well. Other thing I want you to notice is, again, I'm using radicals here. I think Big Ideas uses decimals, but again, I like radicals just because I think the more practice you get with that, the better. Okay. Let's go ahead and try a couple examples. So on your paper, it says solve by graphing. I don't think we need to do a ton of these, but let me go ahead and show you kind of what I would do here. So if you notice, this one all asks you to solve by graphing. So if you're asked to solve by graphing, then you should solve by graphing. So this one is kind of weird because I wouldn't normally solve this by graphing because if you notice, there's no x squared term. But since it tells me that we're solving by graphing, I'm going to go ahead and solve by graphing. And I know my graph is going to be a little different. So I'm going to go ahead and set this equal to 0. So I get negative x squared. If I subtract 13, I get negative 25. So I get negative x squared minus 25. I'm going to grab my calculator. I'm going to go to my y equals, and I'm going to type that equation in. So use the negative button. Remember, the negative button's down here. And then x, and then the squared button. And then what is it? Minus 25. So minus 25. If you're going to solve by graphing, you obviously have to look at the graph. Now, my graph had some stuff in it when we did like that quadratic regression. So remember all those little, dots and everything. To get that off your screen, if you hit second y equals, and then where it says plots off number 4 and hit enter, that kind of takes off the scatter plot thing. And then I'm going to go ahead and hit zoom 6 and see if I can get a good picture of this graph. Let me zoom in on here. All right, I'm not seeing h because if you look at your equation, you're right, x squared minus 25. Let's see here. Okay, negative x squared minus 25. I need to, let's go with a y minimum of like negative 50. I know that sounds a lot, but because of the fact that if you notice on your equation, your c value is negative 25. That means that's your y-intercept. So this is what my parabola looks like. All right. So again, this y-intercept there is 25. So I'm going to put this back up a little bit just so I don't scare you with my... All right. So let's say like this is my equation. Okay. How many solutions does this equation or does this graph have? So if I asked you to solve this, and we haven't learned imaginary yet, so the number of solutions would be the number of times it crosses the x-axis. So do you see this crossing the x-axis at all? Because I don't. So in this case, you would say this has no real solutions. And the reason why we specify real is because we're going to get into ones that are imaginary. And so we want to specify that those are not going to be real solutions. You can still graph a parabola that has no real solutions, which I know sounds weird, but it's basically a parabola that either hovers above or hovers below. All right, let me go through a couple other examples. So notice there's no b value here, or t value, I guess. So you would use square root method. This looks like more vertex form, so we use square root method. Notice this is a p squared and p squared, but there's no p's in this equation. I would use square root method. So all of these are going to be using the square root method. I'm going to go through this middle one here, number 5. I'm going to show you one that's in kind of vertex form, even though this isn't in complete vertex form, but it's close enough. So I'm going to add 19 to both sides. So what you want to do is if you have like a quantity squared like this, you want to isolate it. In other words, get rid of any other numbers around it. At this stage, you can get rid of that squared by square rooting. Don't forget your plus and minus. Square root of 100 is 10. And now you're just going to solve this equation. So I'm going to subtract 3. So be careful. I'm going to write it like this. So plus and minus 10 minus 3. And then I'm going to divide by 2. So plus and minus 10 minus 3 over 2. It looks a little weird like this, so we're going to go ahead and write out our two solutions. So what this means is you're going to say, okay, let's start with positive 10. So 10 minus 3 is 7. 7 over 2 is 3.5. And then my other value for k would be negative 10 minus 3 is negative 13. Negative 13 divided by 2 is negative 6.5. So now you know that the graph is going to touch the x-axis at negative 6.5 and positive 3.5. And that's solved by square roots. I will have you guys maybe practice the other two for those of you who need some extra practice with this. I wanted to go through an example of one where you can solve using your graphing calculator. And I'm showing you this one because not so much that we're going to be using it a ton in class, but I know some standardized testing, eventually you guys are going to get there if you haven't already. You're going to be using, a graphing calculator quite a bit. And if you want to have a way to kind of check your work, this is an option for you. So I'm going to show you how to solve a quadratic equation by using your graphing calculator. So I'm going to pick an equation that doesn't have really nice solutions. In other words, they're not integers. They're not going to be like x equals 4 and y, x equals negative 2. So I want to pick ones that are a little bit messy because that's the whole benefit of having a graphing calculator is that we can look at all variety of kind of solutions. We don't have to be, narrowed down to just the ones that work out or factor nice and pretty. All right, so again, remember, step 1 when solving. And so this goes with solving for any kind of solving. We're going to set this equation equal to 0. So I'm going to put it in order too, right? So if I set this equal to 0, I want to subtract 5x from both sides, but I don't want to put the 5x at the end. I want to put it in the middle, just so it's in standard form. Next, you're going to grab your calculator. And I'm going to erase this out of here. And so what I'm going to do is I'm going to enter this equation into my graphing calculator. So negative 2x squared minus 5x plus 9. And so all I'm doing is entering that into my graphing calculator into my y equals. I'm going to hit graph. And now my window setting is a little bit off. It's not 100%. I'm going to go ahead and change it back to my standard screen, which is zoom 6. So zoom 6. I get a pretty good picture. I don't really get to see the top of the graph, but to be honest with you, if I'm looking for solutions, I don't really need to see the top of the graph. All right, so what I want to do, if you might notice that these lines, if you look real closely, they do not touch the x-axis at a real specific point. It's really hard for, I don't know if you can see that, but it's really hard for you to estimate what those values are. And the best you could do would be estimate. So what we're going to do is I'm going to show you how to zero in on these. If no one's ever taught you this, this is how you can use your calculator to kind of find those intercepts. All right, so you're going to hit second trace. You bring up to the screen. We are looking for zeros, so you're going to hit number 2. You see how you have a cursor here. You only want to use your left and right arrow keys, and that's just because it moves it along the parabola as opposed to, moving it off the screen here a little bit. So I'm going to move this. If you notice, it says left bound. So I want to move this to like the left side of my 0. So like kind of look at that x-intercept, kind of if you were flatten that out, where would the left side be? So that's about right there. And again, it doesn't really matter where you put it as long as it's to the left. I kind of put it close to it. And then it says right bound. So I'm going to move my cursor down. And again, if I would have flattened that out, this would be the right side of my 0. I'm going to hit enter. So on my calculator, it kind of gives me like 2 lines. I don't know if you can see that here. You can kind of see it, maybe a little. And so anyway, what it's basically doing is kind of zeroing in, zooming in on that one specific spot. It tells you to guess. I don't know why it does that. But anyway, we're going to pretend that doesn't exist, and we're going to hit enter. And look what it does. It puts right there on the 0. And so at the bottom of your screen, I get a 0 of 1.21 approximately. So my solution would be x equals 1.21 if we round to the nearest hundredth. Now remember, there's 2 solutions, so you have to do the same process again. Second trace. Go down to number 2 for 0. Sorry. Graph, second trace. Go down to number 2. I'm going to move my cursor, so I'm going to hit my left arrow key all the way over. And there it is. And I want to go, so if I flatten this one out, this below would kind of be where the left side of my graph would be. So I'm going to hit enter, arrow it up, hit enter again. This time I get a solution of negative 3.71. And so this is an easy way to kind of find your solutions on a graphing calculator. And I know that the steps are, I would maybe practice this a little bit, but it does get really easy the more you do it. So I would be happy to kind of go over it again in class, but you are welcome to practice this and kind of use this as definitely as a backup plan if ever needed, and especially if you're taking any kind of standardized test. This is a nice process. Okay, let's move to page 49. So on page 49, we have a whole bunch of different kinds of examples. I wanted to go through some. And so sorry, trying to get a better picture. There we go. So it says solve the equation by factoring. So I'm going to go ahead and go through an example of factoring. I'm going to do the hardest one, which is number 9. So I'm going to skip 7 and 8. I'd like you guys to do those maybe if you want some additional practice, but I'm going to start with number 9 because it's the hardest. So notice that I have like x squareds and x's on both sides of my equation. Notice that I have an x squared, an x, and a constant term. Okay, great. So that's kind of how you know it's a trinomial, so you know you're gonna factor. I'm gonna set this equal to 0. So I'm gonna add x squared to both sides, and then I'm gonna subtract 4x. And this is what I get. So again, I'm setting this equation equal to 0. If it's a trinomial, you should set up 2 sets of parentheses. My preferred way of factoring is by guess and check. And so factoring is something I know that you guys learned in Algebra 1. If you need additional practice, please let me know. I can always, meet with people or do like kind of like a little study session with it or whatever. It's just one of those skills that you really need to have kind of mastered at this level. So anyways, what you do is you look at this first term, which is 6x squared, and you say to yourself, what 2 values multiply together to give me 6x squared? I'm going to choose 2x and 3x. And again, it doesn't really matter which order. I know I could have used 6x and 1, so that was an option. This is why they call it guess and check, because you're supposed to guess and then check your answer. Don't just take the first one that comes along. So you figure out what multiplies together to give me 6x squared. Then you look and see what multiplies together to give me 1. Well, the nice thing here is there's only one option, right? 1 and 1. The only thing you have to figure out now is like signs. So in order for me to get -1, these have to multiply together to give me -1, but add to +1. So how I check this is the check part. You kind of FOIL this out. So 3x times 2x is 6x squared, right? 3x times 1x would be 3x, and 1 times 2x would be 2x. So by FOILing this out, I need this middle term to be +1, which means I need this to be positive and this to be negative. That's the only way I'm going to get that to be +1. So I need this to be positive and this to be negative. So when I multiply 3x by 1, I get positive 3x. And when I multiply -1 by 2x, I get negative 2x. And then if I continue to check, I would get -1 times 1 and give me -1. That's how you know you factored it correctly. If you have another strategy that works, as long as it's quick, I guess I really don't care how you kind of arrive at the factoring, as long as you're able to do it in a quick manner. I know there's a lot of different methods out there. All right, so now we're going to use that zero product property, which basically just says take your factor and set it equal to 0 and solve for x. So I get x to equal 1/3, and then I have 2x plus 1. I'm going to do the same thing. I get x to equal -1/2. So again, in most cases for a quadratic, you're going to get two solutions, not all. And so I got these two solutions for that one. Okay. In number 10 asks you which equations have roots that are equivalent to the x-intercepts of the graph shown below. I'm not going to do this one together. I think it'd be a good idea for you guys to kind of do that one on your own to kind of practice. Gives you kind of some practice solving a whole bunch of different forms of equations and seeing which ones match the graph here, match the x-intercept. So I encourage you to do this without a calculator. Try factoring, that kind of thing, because factoring or square root method, because ultimately that's what we're trying to get you to be able to do. I do want to go over number 11 though. So number 11 says a sky story problem, right? So we always want to make sure that we kind of practice some of those. I know a lot of you had asked me to kind of make sure we include some more. So it says a skydiver drops out of an airplane that is flying at an altitude of 4,624 feet. Use the formula h equals -16t² plus h of 0 to write an equation that gives the skydiver's height in feet during a free fall, which is t seconds, after the skydiver drops out of the airplane. All right, so we're writing a formula. So that's a lot of words to basically do this. They're saying that this is your initial height, right? So your constant term. So they're giving you this equation. They're saying, well, plug this in for h of 0. H of 0 means initial height. Again, that's more of like a scientific kind of way of saying it, but that's all it's really referring to. All right, so then it says, write an equation. That's all we had to do for part A. For part B, is it possible for the skydiver to wait 18 seconds before pulling the parachute cord? Well, think about this. If he's a skydiver, right, starting up here, and here's the airplane, he's jumping out of the plane. And so the parabola is opening down, right, because number one, there's a negative, but also, you know, he's heading towards the ground. He's not floating off into outer space. Is it possible for the skydiver to wait 18 seconds? They're asking for your t value here because it's talking about seconds. So remember, your x kind of is your t, so that's your time, and your y is your h, which is your height. So what you want to do here is you want to solve the equation. So you want to figure out what's this x-intercept, because that'll tell you the total time it takes him to get to the ground. So I'm going to set this equation equal to 0. And I would like you to think in your head right now what method you would use to solve it. Would you factor this? Would you go ahead and put in your graphing calculator? Or would you use the square root method? I hope that you would say that use the square root method. And the reason why is because there is a t squared but no t term. So this one is a fairly simple one to solve algebraically, and definitely something that I'm going to want you to be able to do. So move that 4,624 to the other side. -4,624. I'm going to divide by -16. So I get positive 289. And then if I square root both sides, I get plus and minus 17. So what does this mean? It means my x-intercepts are at 17, 0 and -17, 0, which this one doesn't really make sense for this problem because that would mean like he started like 17 seconds, in the hole or something. So that doesn't really make sense in the context of the problem, but nonetheless, we have this one does make sense. So is it possible for the skydiver to wait 18 seconds? The answer is no. He will be on the ground in 17 seconds. So if he waits 18 seconds, that's going to be a little bit too late. So the answer to that question is a resounding no. So if any of you ever parachuted, you know that I would imagine that would be a scary thing to do. I've never done it. Really no desire to, but nonetheless, in this case, you get to the ground pretty quick, so don't wait. All right, I know this was a little bit longer video, had a lot of good stuff in it in terms of solving, definitely something worth kind of, practicing and so forth. If you have any questions, bring them to class. All right, bye guys.